Okay, in Unit 2, we're going to discuss some of the major tests of null hypothesis. Just go real quick. You're not going to learn on a presentation. This is another one. You got to get in the videos and do the work on the quiz. We got 4 tests. The first one's the z-test, and this is the probability of getting a single result as a result of random chance. Then we got the student t-test, and this is actually we compare 2 groups and see if they're different. ANOVA, where you got more than 2 groups you can compare to, and chi-square, which is basically a discrete function. You want to compare 2 or more variables. The first test we're going to talk about is the z-test. This is for variable data. That's data like time, money, weights, whatever. And what you got to do is calculate the z-score. Now, the z-score, what it does, it takes whatever data you have and converts it or normalizes it so you can use the standard normal table. So you standardize or normalize this, and then you plug in the table. Don't do it that way. Look at that norm dis video that I put in the readings and do it that way. That's the z-score. If you have a group of people, you can take the average. Say you got a class, they take a test, they score an average of 82. Well, your standard deviation then is the standard deviation of the population divided by your sample size, the number of people that took that test. And what it does, it tightens up that variability. And you plug that into the norm dis function, and it'll give you a better estimate of the probability of random chance. Now, the null hypothesis is that there is the number you're looking at is not significantly different from any other member of that population. That's the null hypothesis. The t-test is another one for variable data, and this was developed by old Willie Gossett back at Guinness Brewery about 120 years ago. So what he'll do is he'll take 2 sets of data, or groups, and he'll take those and he'll compare them to each other to see if there's a significant difference, statistical difference. This null hypothesis, there is no difference. Watch that video again and do the look at the spreadsheet I sent. I attached that video twice and read these and the discussions and see if it doesn't make sense. If you have questions, ask, okay? The ANOVA, if you have more than 2 groups, you can use the ANOVA, analysis of variance. This was developed by Fisher, which usually compare 3 or more different means. You can determine where the variability is. I sent you that gauge R&R. That's based on ANOVA. Where's the variability? Is it with the guy taking the measurement? Is it in the instrument? Is it part to part? So it's based on the F-test. If you do an internet search for ANOVA in the internet, they'll have these calculators. Use one of those. And if you have trouble with it, send me the calculator you used. Let me see if I can make it work. Again, ANOVA. What you have here is a chi-squared. This is discrete data, so you do the observed versus expected. So let's say you want to look at men and women, where they voted for Republicans, Democrats, or Independents. You could separate that and ask how many actually voted for the Republican, how many voted for the Democrat, how many voted for the Independent. And you can compare the two. And again, the question is, was that just the difference I'm seeing between men and women, just random variables, or random variation, or is there something really going on? Again, discrete data, the null hypothesis, there is no difference between the two. Take a look at the videos and spreadsheets. Ask if you have some questions. And that's all I'm going to cover on this. And here are the links.